find the curvature of this curve at the point 1, 0, 0. And here is one formula for curvature where we find the derivative of the curve and take the cross product with second derivative of the curve, and we take magnitude divided by just the derivative magnitude cube. So let's find first derivative and second derivative. We can rewrite this function in component notation, this vector function. So this is t squared, this is natural log of t, and this is t ln t. Then derivative is just find the derivative of each component. This is 2t 1 over t, and derivative of t times ln t is a product, so we need to use the product rule. So one derivative of t is 1 ln t plus t times derivative of ln t, which is 1 over t. So t times 1 over t, just 1. And let's find second derivative as well. Derivative of 2t is just 2. Derivative of 1 over t, just find somewhere. This is t raised to negative 1, so negative 1 over t squared. And here derivative of ln t is just 1 over t. Okay. Now we need to evaluate these derivatives at t parameter t value, but we are given a point 1, 0, 0. I mean, this 1 corresponds to first component. Let's look at here, t squared, and second component corresponds to this. Third component corresponds to this. From this we should be able to find the parameter t value. Just looking at first, t squared equals 1, that means t should be 1 or negative 1, but natural log of negative 1 is undefined. Or we can look at natural log of t equals 0. Natural log of t equals 0, that's when t equals 1. ln 1 is 0, and that satisfies other components as well. So the parameter value is t is 1. Okay, t is 1. Now with this, then r prime t, this is 2 times 1, 2, 1 over 1, just 1. Natural log of 1 is 0 plus 1, just 1. How about second derivative? At t equals 1, this is 2. Negative 1 over 1 is squared, just negative 1, 1 over 1. Now we need to find the cross product of these two vectors that's needed on the top. And we need to find the cross product's magnitude as well as cross product of this vector. Let's find the magnitude of this vector, which is needed on the bottom. Square root of 2 squared, 4 plus 1 plus 1, that's root 6. Okay, that goes on the bottom of this formula. Find the cross product, r cross r double prime, r prime cross r double prime, that is I, j, k. R prime is 2, 1, 1. R double prime is 2, negative 1, 1. Let's evaluate this. So with I, this is 1 times 1, 1 minus negative 1, so 2, 2i, or we can write in terms of component notation. How about j? This is 2 minus 2, 0, so negative 0 is 0. For k, that's negative 2, negative 2, negative 4. And let's find its magnitude. That goes on the top here. So magnitude of this vector, which is 2, 0, negative 4, is square root of 2 squared 4 plus 0 plus 16, that's 20. Okay, we leave 20 for now. Then using this formula, okay, then the curvature kappa is the magnitude of cross product goes on the top, root 20, and magnitude of r prime cubed, so root 6 cubed on the bottom, that's root 20. So if we keep one copy here, 6, and root 6 is squared, cancel 6, so this is 1 over 6. You can just simplify the way you like, 10/3. Okay, that's root 10 on the top. Okay, if you like you can go further, but I'm gonna leave here, and that's the final answer. Okay, root 10 over 6 root 3.